Hi, year 11s, this is Mr. Lim here again, and this is the last video on gases and its gas calculations. So let's get started. Okay, so gas calculations, what units we need, what's this SDP idea, and then do some calculations. All right, so let's get started. Gases use three properties or have three properties that can be used to calculate information about them. Right, number one is pressure. Its unit is kilopascals. Then we have volume and temperature. All right, pressure also can be given in atmospheres, where 1 atmosphere is 101.3 kilopascals, but you will need to convert that unit into kilopascals. All right, so 2 atmospheres would be 202.6 kilopascals, so that's the idea. All right, we've already went through temperature conversions and volume conversions from mils to liters. You better be able to do that. All right, so we use these three properties to determine the number of moles or something, or we use the number of moles to determine one of the other properties given the other two. All right, so the conditions of a gas are relevant to the calculations. So we can do two types of calculations to work out the number of moles of a gas. So the idea is that we just went through pressure and temperature and how they affect volume. So we need to know those conditions so that we can work out the number of moles of a particular gas. All right, either the gas is at standard temperature or pressure, or it's not. Okay, so we're going to talk about what those are. So let's go. So what is standard temperature and pressure? Standard temperature and pressure is 0 degrees Celsius or 273.15 Kelvin and 100 kilopascals. All right, at standard temperature and pressure, 1 mole of any gas, that's any gas, will occupy 22.71 liters of space. Because these two, and why it's for any gas, because these two conditions are relatively high temperature and low pressure, most gases will act like ideal gases at these conditions. All right, and since they're all acting like ideal gases, the difference in the size of the particles is negligible compared to the space between them, right? And thus, the type of gas that you've got is irrelevant, right? Because so any type of gas at STP will occupy 22.71 liters of space, right? Therefore, the N of a gas at STP is equal to V over 22.71, or if you want to write it out properly, N gas will be equal, well then now remember you have to actually start to annotate. It's either at STP or not at STP. Is equal to V over 22.71. Okay, and this is found in your data sheet as well, so you don't have to memorize it. All right, and we're going to be doing calculations in class, so you can have lots of practice doing that. Okay, if it's not at STP, though, so any other conditions other than standard and temperature and pressure, we use the ideal gas law, right? And what is the ideal gas law? It's this equation here. PV is equal to nRT, where P is equal to pressure, V is volume, N is moles, T is temperature, and then this R is this universal gas constant, which is effectively a number, which again is found in your data sheet, right? And it's always 8.314. So you just have to type in 8.314 into that space there, all right? So what you have to remember is that you need to be able to rearrange this equation, okay? So brush up on your algebra skills to any format to get any of those values, but also you need to remember to convert all units to the appropriate type. We're going to be practicing this calculation lots in class, but those two calculations are some of the ways that you can get the moles or use the moles to get other information about these gases. All right, and that's it. We'll be doing lots of practice calculations. Adios.